Hi everyone, in this presentation we will discuss the common challenges faced by the new Liquid Galaxy contributors and how to approach them. So this presentation is about understanding the Liquid Galaxy ecosystem as a whole, and more importantly, identifying the real challenges that a new contributor face when they try to work with the Liquid Galaxy for the very first time. So Liquid Galaxy is not a typical software project. It is a distributed multi-machine setup, which means contributors are not just dealing with the code but also the operating system. So Liquid Galaxy is not a typical software project. It is distributed in multi-machine or multi-screen visualization system, which means contributor are not just dealing with the code but also with the operating system, networking synchronization, visualization tools, and automation. So because of this, many beginners feel overwhelmed even before they start contributing. So the main focus of this presentation is not just to list out the problems but to explain why these challenges exist and how they can be approached in a structured and practical way. And especially most of the new contributors struggle not because they lack ability but because they lack the system level understanding and the guidance. So overall the presentation acts as a guide for beginner, helping them to move forward from initial confusion to a meaningful contribution within the Liquid Galaxy community. So now we'll go to the next slide, which is our agenda slide. So in agenda slide, I'll explain the agenda of today's presentation and what major areas we are going to focus on. So the goal of the agenda is to give a clear structure to the discussion and also highlight the most common problem areas focused by the new contributor. So first we will talk about the contributor mindset, debugging practices, and learning strategies. So the section focuses on how contributors should think while approaching an open source project like Liquid Galaxy, and it includes how to handle mistakes, like how to debug systematically and how to learn from existing code and community discussion instead of feeling overwhelmed. Next, we will move to understanding the Liquid Galaxy system. So here we will look at the overall structure of the system, including how different components interact with each other. This is important because many issues arise simply due to a lack of system level understanding rather than the coding errors. Now, after that, we will discuss environment setup and system configuration issues. So this includes operating system requirements, dependency installation, display setup, and common configuration mistake. Then we will cover synchronization, timing, and data flow difficulty. So this is one of the most important technical area. So as Liquid Galaxy relies on heavily on synchronization updates across multiple screens, so even small timing issue can break the immersion. So understanding the data flow is essential. Next, we'll explore networking, SSH, and multi-machine communication challenges. So, since Liquid Galaxy runs on multiple machines, contributor must understand how machine communicate, how SSH-based control work, and how network misconfiguration can cause system failures. And we will also discuss tooling challenges and especially working with KML, Google Earth, and automation scripts. So these tools are powerful but unfamiliar to many new contributors, and incorrect usage can lead to unexpected behavior. So finally, we will address architectural challenges in a distributed multi-screen setup. So this section files everything together by explaining how architecture decision affect performance and scalability and maintainability. So overall, the agenda ensures that we can cover both technical challenges and practical learning approaches, so which will helping new contributors becoming confident and effective much faster. Now next is introduction to the problem space. So Liquid Galaxy is a powerful and feature rich open source visualization system, but it is not a simple application like an web application or standalone program. It is a distributed system that runs across multiple machines, control multiple displays, and depends on synchronization, networking, automation. So because of this complexity, the learning curve is naturally higher. So many new contributors come in with strong coding skills, but they may be comfortable with programming languages, writing scripts, or building applications. However, they often have limited experience with the distributed system where multiple machines must coordinate and behave as one unfilled system. So the concept is like master slave architecture, network communication, synchronization, timing, and remote execution are one of them. This gap between coding ability and system level understanding often lead to confusion and frustration, and contributor may face issues during setup, see unexpected behaving during execution, or struggle to understand why small changes affect the entire system. These challenges are common and expected, so they are not a sign that a contributor is weak or unprepared, but by understanding these challenges beforehand, contributor can approach the system with the right mindset and more systematically and avoid unnecessary mistake. So next we have who are new Liquid Galaxy contributors. Most of the new contributors are students or early career developers like me, and they are often enthusiastic, motivated, and eager to learn. Many of them have good fundamentals in programming and problem solving, but they are still in the early stages of their professional journey. A large number of them are also first time contributors to large open source projects. So contributing to open source is very different from working on personal or academic projects. So the code base is bigger, documentation may be scattered, and changes can affect many people of the system. So this can feel intimidating at the first time. Then another common trait is that many contributors are new to Linux based system. While they have written code before, they may not be fully comfortable with Linux command package management, system permission, SSH, or process control. Since Liquid Galaxy relies heavily on Linux system, this becomes an important learning curve. So the most important point here is these contributors are usually capable and intelligent. The main challenge is not lack of skill but lack of system level thinking. So Liquid Galaxy requires contributor to think beyond individual files or function, and instead understanding how multiple machines, service, and display work together. And once new contributor develop the system level mindset, they are able to adapt quickly and make meaningful contributions to Liquid Galaxy. And then we have the next slide, which is understanding the Liquid Galaxy ecosystem. So first, Liquid Galaxy involves multiple machines working together. So each machine has a specific role, such as coordinating action or rendering visual. Because of this, a change made on the machine can directly impact how other machine behave. A misconfiguration or timing issue, the entire immersive experience can break. And another critical part of this ecosystem is networking. All machines communicate over a local network. Even small network issue like latency, IP mismatch, or connectivity problem can cause visible errors such as lag, desynchronization, or incomplete rendering. So the system also relies heavily on automation scripts. So these scripts are used for setup, launching application, synchronization, and control. And the key takeaway from this slide is that every part of Liquid Galaxy ecosystem is interconnected. Everything is interconnected. So new contributor must understand that a small change in one area, whether it's code or configuration, networking, scripts, or KML files, can have system wide effect. Then next slide we have the understanding overall system architecture. So when someone new joins Liquid Galaxy, it's very tempting to jump straight into scripts or code files, and start making changes. So this usually happens because contributors are eager to fix something, or to add a feature as quickly as possible. However, Liquid Galaxy is distributed system, not a single application. and this makes the architecture extremely important. So the main issue is that the contributors do not first understand how the entire system works together. They may not know how the master node communicates with the slave node, how user input flow through the system, or how camera updates are synchronized across multiple screens. So without the understanding, it becomes difficult to predict how a small change in one script or configuration file will affect the rest of the system. So because of the data flow is not clearly understood, contributor often make incorrect assumptions. For example, they may assume a script runs on all machine when it actually runs only on the master, or they may modify the slave side process expecting it to control global behavior. So these assumptions usually result in broken behavior such as screens going out of synchronization, command not being executed, or visual glitches, and which appears across all the display. Another challenge is that synchronization issue often looks like other problem. They may appear as rendering bugs, camera misaligned, or even hardware issue. This makes debugging difficult, especially for new contributors who are new to the distributed system behavior. Then next we have the correct way to think about synchronization. So the first idea is that synchronization must be centralized, and the second important concept is that synchronization must be time consistent. It is not enough for all machines to receive the same command. They must apply that command in consistent and predictable timing window. Synchronization must be controlled by the master node. The master node maintains an authoritative camera state and decides exactly when to update and where should be the camera position. A very important rule for contributor is that slave nodes should never attempt independent timing decision. And then we have the next challenge, understanding KML and camera control. So many contributors are unfamiliar with KML. When they first join the project, they may have seen a file format used to mark location on a map, but in Liquid Galaxy, KML plays as much as important role. So it is not just a static data, it's a dynamic control mechanism that directly influence how the camera moves, rotates, and synchronize across multiple screens. So a common mistake new contributor make is treating KML file as something that is loaded once and forgotten. Another issue is that contributor may try to control the camera independently or different machines using KML. Since Liquid Galaxy relies on single authoritative camera state, this breaks synchronized and causes inconsistent visual across display. So the next slide is how to approach this KML based control. So the first important point is that contributor must understand camera parameters deeply. KML camera elements such as latitude, longitude, range, tilt, and heading are not just values on the map. Together they define how the viewer experience space. So a small change in range affect zoom level, a small change in tilt affect depth perception, and heading control orientation. So without understanding what each parameter does and how they interact, contributors may unintentionally create unstable and confusing camera behavior. And then next we have the challenge 8, automation scripts complexity. So a very common mistake new contributor make is running scripts without reading them first. So because scripts often have descriptive name, contributors assume they are safe to run and will do exactly what they expect. So but however, these scripts may modify system files, restart service, kill running processes, or make assumption about the environment. So when run blindly, they can cause behavior that feels random and hard to explain. And another issue is that automation scripts are often written with assumptions. They may assume a certain directory structure, operating system version, networking setup, or SSH configuration. So the next slide we have the safe practices. What are the safe practices for working with automation? So the first and the most important best practice is reading script before running them. And the second important practice is adding logging and checks. So scripts that run silently are difficult to debug by adding clear log messages And validation checks, contributor can immediately see which step is being executed and where the failure occurs. So this makes automation more transparent and significantly reduce the debugging timing. Another key practice is testing scripts on minimal setup. So before running automation on a full multi-screen installation, contributor should test scripts on a simplified or smaller setup. And then the next is challenge 9, debugging distributed systems. So when developers are used to working on single application, debugging is usually straightforward, but if something breaks, the cause and effect are often in the same place, so within the same process or the same machine or the same log. However, Liquid Galaxy works across multiple machines, and this completely changes how problem appears. So in a distributed system, the source of a problem and its visible effect can be on different nodes. So for example, an issue might originate on the master node, such as incorrect timing or failures or a failed command, but the visible symptom appears on the slave node or as a frozen screen or delayed update. And another complication is that failures are often partial, not total. And distributed debugging also required contributors to check multiple logs, machines, and process at the same time. The next we have effective debugging strategies. So one of the most important practices is checking logs of all the nodes, not just one. And another key strategy is verifying assumption layer by layer. Instead of assuming that the network is fine or the SSH is working, contributors should explicitly verify each layer: networking, connectivity, SSH access, script execution, synchronization logic, and final rendering. And then next we have the last challenge, which is challenge 10, contribution anxiety. So one of the major reason for this anxiety is that code base feels very large. So new contributors open to repository and sees many folders, scripts, configuration files, and tools. So without prior context, it can feel overwhelming, and the contributor may not know where to start or which file is are safe to touch. So and another strong factor is that fear of breaking things, because Liquid Galaxy is distributed system involving multiple machine and display. Contributor worry that even a small change could break the synchronization or affect the entire setup. So this fear can cause contributor to hesitate even when they have a good idea or have identified the real issue. And the third reason is lack of confidence. Especially for the first time open source contributor, beginner may compare themselves to experienced contributor and assume that they are not ready to contribute yet. So they may worry that their code is not good enough or their questions are too basic. So the important point is to understand that this is a very common open source issue, and almost every experienced contributor has gone through this phase. So contribution anxiety does not mean someone lacks ability. It simply means that they are stepping into an unfamiliar environment. So how to start contributing confidently? So the best way to start contributing is by keeping the first contribution small and manageable. Rather than jumping straight into complex feature or major architectural changes, beginners should begin with tasks that are low risk but still valuable. One very effective starting point is small documentation improvement, and another good entry point is minor script enhancement. This could including adding comments, improving logging, or making script safer by adding checks. So by starting small and contributing consistently, new contributor can gradually move from hesitation to confidence and become active long-term members of Liquid Galaxy community. Now what new contributors ultimately learn? So one of the most important thing contributors learn is distributed system concept. Liquid Galaxy is a real world example of how multiple machines coordinate to behave as one single system. So contributors learn about role, communication, coordination, and failure handling. So concepts are fundamentals in modern large scale system. Another major learning area is real world synchronization problem, and contributor also gain strong skills in system level debugging. And while working on Liquid Galaxy, they also teaches open source collaboration. So contributors learn how to communicate with maintainers, follow contribution guidelines, write meaningful pull request, and review other work. Now we'll go to the next slide, which is conclusion. So new contributor to Liquid Galaxy face many challenges ranging from technical issue like environment setup, networking, synchronization, and automation to non-technical challenges like confusion, debugging difficulty, or contribution anxiety. So, however, the most important point is that none of these challenges are unsolvable. They are natural. They are a natural part of working with the complex real world distributed system. So, when the right approach with the right approach, contributor can overcome these difficulties much faster. And another important takeaway is the value of early recognition. So when the contributor are aware of a common challenges from beginning, they are less likely to feel lost or discouraged. And ultimately, recognizing and addressing these challenges early leads to a better quality of contribution. So while Liquid Galaxy may have a steep learning curve, it also offers a powerful learning experience. And with the right mindset and structured approach, new contributor can grow rapidly and make meaningful long-term contribution to the project. Thank you everyone for watching this presentation up to here, and doubts are welcome. You can post your doubt in the Discord community of the Liquid Galaxy. Thank you.